Hello everybody, this is Miss Abney. In this video, we're going to go over topic 2, lesson 4, example 1, solving quadratic equations using square roots. So in this example, we're going to solve two quadratic equations, basically looking at square roots. So to do this, we have to have a certain type of quadratic equation. And the type of quadratic equation we need for this is the binomial quadratic equation, which basically means there are just two terms. And in this, we have two ways of solving this. We could do x squared equals 16, and we could take the square root of both sides. And when we take the square root of both sides, you want to take the positive and negative, because remember that a negative x squared will give you a positive value, and a positive x squared will give you a positive value. In other words, if I had negative 1 squared, that's equal to negative 1 times negative 1. Negative times a negative gives you that positive 1. And if I had 1 squared, this is going to be 1 times 1, and I'll still give you the same answer. It's kind of like that idea of absolute values, but in this case, we don't have lines. We're working with a parabola. All right, so if I take the positive and negative of 16, the square root of 16 is 4. So we're going to have both positive and negative values for 4 to solve the equation. Basically, what values of x will give me 16 when it's squared? Well, positive and negative 4 squared will give me 16. The second way we could do this is we can do what's called the difference of squares, which means I'm going to take this x squared equals 16. I'm going to subtract 16 from each side. And it's going to be the same idea, but a little bit longer. But we're getting into that format that we want to do for solving quadratics. Well, here we have a binomial, which means that we only have two terms. Usually when we look at a quadratic equation, we have ax squared plus bx plus c. We usually have this third term in the middle. In this binomial, that third term is missing. So what we would want to do is we would want to call this what's called the difference of squares. So we need to do something. We need a p and a q that get rid of this value here. So that means p and q have to be the same number, and one of them has to be subtracting. So in this case, we have negative 4 and 4. So if I add negative 4 plus 4, we get that 0 to get rid of the bx. So now we have x squared. Oh, I lied. We're going to have x minus 4 times x plus 4 equals 0. Because remember, this right here is 0x. And so this would get rid of my middle term. And then again, setting each of these equal to 0, we get x equals plus or minus 4. So again, this right here, what I did here is called difference of squares. And this will show up again when we go to imaginaries in the next couple lessons, where we see complex conjugates. So we're going to use this idea of difference of squares for those complex conjugates. But again, two different ways to solve a binomial quadratic function. Let's go grab the second example. Let's go look at this one. This one is basically the same. We can solve it the same ways. Get a new page here. Oh, except this one has a negative in the front of this 9. So looking at this, is there any type of situation where we would be able to get a squared into a negative? I mean, if you cannot do a negative 3 times a positive 3, because again, we're squaring this. So it'd have to be negative 3 times negative 3 or positive 3 times positive 3. And so this one, in this situation, we'll be looking at something slightly different. So let's think about this. Pause for a second. Think about what kind of situation we would have with this one. So at this point, from your knowledge, from back in Algebra 1, you would say this has no solution, but we are Algebra 2 now. And this does actually have a solution. So we have x squared equals negative 9. I'm going to take the square root of both sides, plus minus. Now, negative 9 has two different factors. It has a factor of 9 and negative 1. So what I can do here is I can actually take the square root of each of these factors. It's still the same. We're still dealing with the same values. We're just expanding it. And so now I have x squared equals the square root of plus or minus, don't forget that plus or minus. The square root of 9 is 3, and the square root of negative 1 is negative 1. Well, we have a special way to denote the square root of negative 1. Remember, math is all about the language and what we're trying to convey. So negative 1 will actually become this imaginary number I. And it's usually a fancy I. Everybody says my fancy eyes look like J's, so I apologize for that. So this would be 3I. And again, I, or the imaginary, is equal to the square root of negative 1. Big concept here. Big idea. And we'll be using this as we go on in our math. Here in the book example, they do just leave it as the square root of 1, but I figured it'd be great to start introducing that idea of the concept of I, or the imaginary. All right, you have two problems here. Both of them are negative. For the try it, I would just keep it as the square root of negative 1. Write your solutions using the imaginary I. So they want you to use the imaginary I, although they did not use it here. Oh no, they do here. They do expand it. Sorry, I did not go all the way to the final part here. So the solution of the equation x squared equals negative 9 are not real numbers, but are part of a system called the complex numbers. The number, the square root of negative 1, is called the imaginary unit, or I. See, they kind of italicize it. Like I said, it's kind of fancy. Replace the square root of negative 1 with I allows you to write the solution to the equation x squared equals negative 9 as 3I and negative 3I. So in here, they do want you to write it out as negative I and I. All right, guys, I hope you have a fantastic day, and we'll see you in the next video.